Hey guys, welcome back to my channel, Re-Engineer Tech, and today we're doing another episode of Souped Up Toys, namely Operation. Now, this is a newer edition. I remember it back when, in the 80s, it had a piezoelectric buzzer in it, one that would scare the pants off of any kid that accidentally touched the metal sides around the pieces. I'd have to check my shorts after I hit that a few times, but nowadays, it just has a little vibrate on it. Not shocking enough. Shocking. Well, why don't we just take this then, which is the amazing roulette, a shock toy in itself, and combine it with that so when we touch the sides, it shocks the player. Now, this on its own is up to 6 players. They all stick their fingers on the pads, and one lucky person gets selected to be shocked. I think I can take this and combine it with this to come up with a new shocking version of Operation. That being said, since we are dealing with electrical shocks, don't try this at home. It's for entertainment purposes only. I don't want to see anybody's grandparents go into the hospital because the pacemaker got shorted or somebody's having an epileptic fit. But now we've got that warning out of the way. Sit back and enjoy as we tear this down and see how we can make this monster of a game. Alright guys, so now that we're at the workbench, or at least my computer bench, let's open this up. Take a look at what we're working with here. So it looks like you have the tweezers, which have the metal on them, and the tether. This is actually how they complete the circuit. There's metal around the edges of all the play areas, and when this touches this, so let's flip this over, and you'll see that pretty much this board is just a metal plate with some artwork on top of it, and then that's all attached to this black brick here, and that black brick actually contains the circuitry that we're going to be replacing. So it looks like it's got a tab on the side here and a tab on the side here, so it would be able to be brought through the front where this artwork is, and the artwork is held in place by plastic rivets. Here, 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 and here. So 1, 2, 3, 4, 5, 6 rivets. That being said, if I take those rivets out, they're not coming back. They're going to get destroyed. We need to take a look at how we can get the black box, if you will, up through the front, or how I can take it off of the back. If I take just these 2 rivets here off, I should be able to pull the artwork away just enough to get access. Let's take a look. Take this. Interesting. It says that it requires 2 AA's, but it actually came with 2 AA's. And those are wired in series. As you can see here, this metal plate continues across to the other battery. That shows that there's an electrical connection going through this. So that means that there's going to be a positive and negative. So I can add these voltages together, and that's going to be the actual voltage of the circuit. Each battery is 1.5 volts, meaning we have a total of 3 volts here. So now that we've checked that out, let's take a look at the shock toy. Figure out the other half of this circuit. So on the back of the box here, it says 3 AA's, not included. So there's a switch, a mode, a light, and finger sensing, and a start button. Basically, the guts of that is just going to get replaced probably during this. So that is not the right size. Take this apart. All right, so now that we have the top off, we can see the circuit inside. central circuit board here with 2 momentary switches and 6 LEDs, along with some capacitors. Those are probably going to be to hold the shock charge. We have 6 pads around the outside, which are divided into 2 pads apiece, so when your finger is across them, there's a small gap. I bet that's going to have something to do with making the shock felt. This off, and that will release. So looks like that's the brains. Okay, Q. Basically, what we're going to have to do here is trace all these circuits out, and I'm going to translate it into a circuit diagram. And that way we can see how we can hack this into what we need. All right, guys, so now that we've taken apart that shock roulette and I've taken a little bit of time to really trace things out and try to figure out what was going on, it just became very clear that this was going to be way too complicated of a circuit to integrate for this project. So I went back out online and looked around for a good alternative, and I came back with this. It's just a simple shock pen. Basically, when you depress the plunger on the top, it completes the circuit and it will shock the person. We're going to tear this apart to really see how the circuit's put together and integrate it. So let's go do that. I'm going to be very careful of not pushing this button in because I already tested it out and wow, that was not fun. Anyways, so we need to get this metal slider off. So I'm going to take these, kind of squish a little bit, and that's going to crack any of the adhesive holding the pen together. And since this has ridges on it, I'm going to grab that and then grab the body. You can hear it crack a little bit. And there we go. Now this is cracked down the middle. Aha! Okay. Get our tools here because I'd rather not get shocked again. So now what I'm going to do is I'm going to weave this through here so that way it makes metal contact, and get that under there. That is the trick there. So we have a battery supply here. This comes off over to this chip here. The chip goes across this transistor, and the underside of a button cell is the ground. So this is grounding both this circuit, even though for some reason they use the red as the ground. So it's grounding not only my hand, but it completes the circuit and starts it up. So that means that we need to make sure that the board allows for grounding of the person's hand as well as turning on of the circuit, because I don't want this thing running the whole time. It'll take out the batteries too fast. Okay, that would work. We have a constant ground to the player's hand. Their other finger still touching the positive, but the circuit's not turned on until we close the gap with the connection between the board and the tweezer. That should work. So a simple way of showing this circuit is we have our batteries, we have our IC, and our little person's hand. So we have a negative spot here and that spot there. And so when we push down on the top of the pen, it closes this switch, which turns on the circuit. And since our thumb had to push down on the switch, which has a metal pin through it, we grounded our hand as well. So allows for the flow of electricity through our hand, allowing us to feel the shock. So if we're going to convert this over to a standalone circuit, we don't want to have this switch closed all the time because it will run out the battery. So the switch will basically need to be replaced with the board's forceps. This will come off the IC. Positive, negative, and coming up alongside the forceps will be a pad, so that way we have a shock across the forceps from that pad into the negative of the circuit. So this will be attached to the board with the parts, and that should work. So let's get to dismantling this, and then I'm going to come up with a better form of battery so that way this lasts longer. Same voltage, just larger cells, and we should be able to go from there. Should be a pretty straightforward build. Also, another thing that we wanted to integrate is the LED. That can happen here. That would give us our positive and negative there, and that should still work. .62 volts. So now that we have an idea of what we're going to do with this, get rid of all this junk. Take this back out. Since I need to get at this black box here, it wants to be popped out of the top right here. Since I'm going to be covering this up anyways, I can just cut into this. Be careful with your cutting tools. Cut away from you at all times. Be careful of the cord. Just cut a door here. Oh, there we go. All right, now our circuit is exposed, or at least the box is. There are tabs on the side here. Just hit those and turn this over while keeping some pressure on that so it doesn't snap back into place. You can see there's a tab which is the connection to the metal on the circuit. And this is our whole circuit. Okay, so what we have in here is a switch for turning on this motor. The battery pack connections are here and here. It goes into an IC, which allows for the connection of the gripper. This goes over to a motor, which also is on this IC. I'm going to have to take this apart a little bit more to really understand what's going on this IC. Looks like just a thermal protector, as you can see here. And then you got a resistor. There's two wires coming off, so your negative, which is completed through this part of the circuit here, jumps across here, and then in parallel is this LED here. Also in parallel with the circuit that is getting closed by putting the gripper here is this switch, which allows for the closing of the circuit by using the nose and pushing on the nose. So let's draw up the circuit. That negative line goes over to this other IC, which is the switch. So that goes over to the switch. This is going to be in parallel. Switch goes to the motor. So this goes to motor negative and motor and LED negative. I don't get why they use red for motor negative. And then in parallel with that is the plate. All right, we're starting to make sense of this. Off of the motor is a resistor that goes to the battery. And this also goes over to the battery. Circuit is going to look like this. 3 volts. This one is 4.5 volts. Even though we read 4.62, the batteries are always a little bit higher than what they need to be. Game of operation. Pretty simple circuit. It's just it was packed in there so hard. So now what we need to do is make sure that they come together. Just draw this out as a new circuit. There we go. So we need a 3 AA battery box. So since we want 3 volts here, we have 4.5 volts here. The voltage division is going to be V2, which is the output voltage, equals V1, our input voltage, over, so R2, we're going to call it, and that's R2, R1 plus R2 is on the bottom. By doing this, we can rearrange it. So now it's V2 divided by V1 equals R2 over R1 plus R2. So let's get that number. That's going to be 3 over 4.5. So if we actually see that it's 3 over 4.5, we could infer that R2 is going to be 3K, and that means to have it over 4.5, that R1 is going to be 1.5K. That's just a rough estimate. We might drop those down to make sure our amperage stays up. Basically, that's what you want to watch out for. The higher the resistance, the lower your amperage is going to be. So we could drop that down to 300 and 150 and get the same results. I need to look at the amperage that each component needs. So if I take this and I connect it up to my benchtop power supply and put it across our circuit, turn that on and hit this, we see that we are running an average of 0.26 amps, 27 amps, okay? That means that we need to make sure that our voltage divider is allowing for at least that much current. That being said, we also need to allow for the shock toy part of the circuit to also get the required current. So that is right here. Red is actually our negative. Twist that back on itself, clip. And I'm going to make sure not to touch this terminal because that would hurt. Clip that on there. I'm going to turn this on. And we are looking at about 0.19, 0.2 amps. To add a little bit of wiggle room, we don't want to get right on 0.4 amps. We're going to go for a half amp. We know that the voltage drop across our circuit here, we're starting at 4.5 volts, going down to 3 volts. So that means that's a change of 1.5 volts. So the V in V equals IR will actually be 1.5 volts. And you know that we need a half amp of current. That means you're going to take voltage and divide it by 0.5. Basically multiply it by 2. And that means that we are going to have 3 ohms to get our 0.5 amps. And since we know that we need to have double the resistance here in order to have 3 volts here and 1.5 volts here, that means that this needs to be 6 ohms. So we have a 3 ohm and a 6 ohm. Alright guys, so after taking a look at the setup again, as I kind of feared, the resistance in the circuit is just too unstable for me to adequately figure out what is going on with the current and the voltage. When I tried to simulate it, it was dropping from 3 volts at this point to 2.07 volts. And so that's just unacceptable. I was also getting some feedback, but another way for me to get the voltage that I need for the shock toy is to add a battery off of this point, because that's the positive terminal. So what I'm proposing to do now is, instead of having the 3 battery and getting rid of using the 2 batteries here. We'd still use the 2 batteries inside the regular compartment and then add an extra 1.5 volt AA battery on top, and that would get us up to our 4.5 volts that we need for the shock toy. I have my soldering iron already queued up, so all I need to do is soften up this solder, move that, move this, there, get that out of the way. Now we are back to our normal circuit. So we're going to take 2 AA's, put it in there, and test if it's in working order right now before we move forward. Yep, working order. All right, so now we can de-energize that circuit. Put the 2 on here. We're going to just tack this down in place. This one here will go to our shock toy, which I had to rewire a little bit because as I was doing my test, the 2 ends came off. So this will be connecting to this part, and this should connect right to the other side of this battery cradle here. Let's try that out. We're gonna go in with our soldering iron, tack that in place. There we go. All right, and now not sure why, but we're getting lighting up of the circuit here. This is disconnected. It's just acting as an alligator clip, so that way I don't get shocked. Make sure the other end's not touching me or anything that can conduct. We're basically taking a reading off of our shock circuit. The batteries are coming out. I should not be reading anything from that. All right, so we're getting leakage. That's what we're seeing here, is that we're still getting 8 volts of AC power when this is connected, and we should not be seeing that. All right, so after further investigation and discussion with my buddy Nick, who's also an electrical engineer, we kind of came on the idea that basically when the batteries were in this part, it would work like normal, right? AKA this part was open. And when a battery was in here, we would note that there was some pulsating going on this LED. And from drawing a schematic for it, we determined that there was a ground loop happening across the motor. So in order to try to counteract that, I have a diode here. It's the 1N4001, which is a rectifying diode. Basically, this is going to go between this connection here, which is the motor, and this. And that line means that current can travel this way across it, not this way, going from high to low voltage. So when this is disconnected, obviously nothing's going to happen. So if I take this, and then if I do this, the light lights up. You can see the flashing. So if I take this diode and go like that, no flashing, which means the ground loop is interrupted. Basically, it was traveling out here, coming through here, and going down the ground and traveling backwards up through the motor, allowing for this circuit to energize. And when the AC turned on, which this is a DC to AC converter, it was basically back pulsing across the LED here. So that's one of the most difficult things to figure out, is a ground loop problem, because usually in our analytical models, we assume that it's always going to flow from high to low. But sometimes when you set it up, you don't realize that, hey, your low point temporarily is over here, and it manifests in a weird way like we saw. Take this, prep it. There we go. And we're going to tin this. And now if I go like this, there we go. Trying to rearrange this, make sure it's gonna all fit together here. Just add a little bit of extra solder to my iron. Ooh, that's a little hot. There we go. So now what we should be able to do is test the first portion of the circuit. Okay, now I'm going to put this in. We're going to see if we get any feedback. No feedback. So we're going to look at the AC voltage coming out when I complete the circuit. All right, so that's clipped in. There we go. We're getting 20 volts. Then it goes down to nothing. Perfect. It's working. So this is actually going to go, that goes like that. Clips in. So basically need this to go up underneath. Then this will come over and go out the same hole. Let's see, do I have room now? That there. Just going to drive each of the screws a little bit first. So now I've got my heat gun here. I'm going to put it on the low setting. Just shrink up my tubes. When you're done with these, make sure that you keep everything away from that tip. All right, so this is going to go along here. So if this comes out along here, am I going to have, yep, I'm going to have enough wire to get out to this point so that way we can have the shock. Come back to our board. We want to tuck in the parts that have to go past this first. All right, that's locked in place. So now what's going to happen is this is our ground, right? And so this carries our shock. So when this touches that, it turns on the shock and also grounds across the fingers. So what I want to do is put a heat shrink tube across here. When you're on it, your thumb ends up on the exposed wire and you get your shock. So let's go back to the other side of the board. Bring that around. And we're gonna basically just hot glue that in place and then hot glue this in place as well. And you know what? While we're waiting for that hot glue gun, and take a look at this. So I need to bend that part up out of the way so that way we can get our heat shrink past it. I think this one will work. Yep, that'll just barely work. Use my scissors to cut this to length. Push that on there and now we're going to take the pliers, pull until they cinch back up, pushing this back in place, and then coming in with the heat gun again in a second. So now get that out of the way, take this, put some hot glue, there we go. Now that's tacked in place. A little bit more hot glue here to hold those wires in place, and then let's see if I can do something about how fast this is cooling. Yep, so that worked. Got some of that duster. If you turn it upside down and be very careful with it, basically outputs really cold liquid CO2. So that actually will cool your glue almost instantaneously, especially if it's like low temp glue. That stuff takes forever to solidify. All right, so now we're gonna go in and we're gonna hit this with the heat gun. There we go, look at that. Oh man, that's gonna be perfect. So that's gonna be our insulative surface. All we need to do is cut this to length and tack that in place. I'm gonna wrap it, tack this in place. And then we're gonna take a little bit more hot glue. And again, we're gonna set that using the spray can method. And there you go. Now you've got your contact on either side and it's insulated from the ground. All we need now is to finish off the artwork replacement to finish the story of why you're getting shocked. So we're going to print off a new board for this, do some cutouts, and we are set to go.
Shut up and sit down.
So I got my artwork placed here. It's all fitted in. I've trimmed it. Why don't I just cut this out and see what happens, and we'll go from there. Exhale a little bit. Hold it. You'd literally...
Wait, does it knock out?
The patient died, but technically it was a successful procedure.
Oh my gosh! Oh my gosh!
Testimonial.
Great game. Great for ages 3 and up.
Unfillable thumbs up.
Nice.
Is it up or is it down?
Alright guys, so that completes this build. As you can see, I've also added some new artwork. It's Frankenstein's monster. This gives us a little more backstory as to why we as the players are getting shocked, and also allows us to cover up the modifications that damaged the original artwork. As you noticed, it was well received by my friends, which was awesome. It made all the frustrations of finding that ground loop worth it. In its current configuration, there's a shock-free and a shock full version based on putting in or taking out the extra battery. That being said, some of the feedback was that people wanted to have varying levels of shock available. So make sure that you subscribe so that way you don't miss that video in the future. If you happen to have any questions or comments, make sure you leave it down below. I love talking to you guys and seeing what you guys think about my videos. And as always, thanks for joining me.